Imagine you're in a room with two doors. You exit through one, but somehow you come back in through the other. Puzzling, isn't it? Picture this. You're not just going through one door at a time, but both simultaneously. An impossible feat in our everyday reality. Yet, it's the norm in the realm of the tiny particles that make up our universe. This concept is known as quantum superposition, and it's just one piece of the quantum puzzle. Now imagine two particles separated by vast distances, yet intrinsically linked. Change the state of one, and the other responds instantaneously. This is quantum entanglement, another enigma of the quantum world. But this isn't some abstract science fiction or a philosophical musing. These mind-bending principles are being harnessed to solve complex problems that our current computers struggle with. What if I told you this isn't just a mind-bending riddle, but the heart of an emerging technology set to revolutionize our world? Welcome to the universe of quantum computing, a realm where the conventional laws of computing take a back seat and the principles of quantum mechanics take the wheel. Quantum computing, an exciting and rapidly emerging technology, promises to solve complex problems that classical computers struggle with. Now, let's dive a little deeper. Classical computers, the ones we use every day, operate using a binary code of ones and zeros, a system that depends heavily on transistor technology. But quantum computers, they dance to a different tune. Enter the qubits, the fundamental units of quantum computing. Unlike the binary bits of classical computers, qubits can exist in a state of superposition, which means they can be both 1 and 0 at the same time. This ability to exist in multiple states simultaneously gives quantum computers their superior computational power. But that's not all. Quantum computing also utilizes a principle known as entanglement. In this fascinating quantum phenomenon, pairs or groups of qubits can become entangled, meaning the state of one qubit is directly related to the state of another, no matter the distance between them. This allows for a level of coordination and communication between qubits that classical bits could only dream of. Now imagine a computational space that is not just two-dimensional, but multi-dimensional. That is the playground of quantum computers, a space where complex computations can be performed with a level of efficiency that leaves classical computers in the dust. IBM, a pioneer in this field, is pushing the envelope with its quantum processors that use superconducting qubits operating at ultra-cold temperatures. They're not just making quantum computing more powerful, but also accessible, with advances in both hardware and software. Quantum computing is not a distant dream, but a rapidly evolving reality, and IBM is at the forefront of this revolution. IBM Quantum is leading the quantum race, pushing the boundaries of what's possible. Imagine a world where complex problems that leave classical computers struggling can be solved with ease and efficiency. This is the promise that quantum computing holds, and IBM Quantum is at the forefront of making this promise a reality. IBM Quantum is taking quantum computing from the realm of theoretical physics and bringing it into the practical world. Their quantum processors use superconducting qubits that operate at ultra-cold temperatures. What does this mean? Well, in a quantum computer, the basic unit of information is the qubit, akin to the binary digits, or bits, used by classical computers. But unlike bits, which can be either 0 or 1, qubits can be both at the same time, thanks to a property known as superposition. This allows quantum computers to perform multiple calculations simultaneously, drastically increasing their computational power. But quantum computing is not without its challenges. Quantum information can be fragile, and errors can easily creep in. This is where IBM Quantum's developments in error correction and mitigation techniques come into play. These techniques are designed to improve the performance of quantum computers, even in the presence of noise. IBM Quantum is not just creating quantum computers, they're laying out a roadmap to scale quantum processors, a critical step towards achieving what is known as quantum advantage. This is the point at which quantum computers can solve problems that are beyond the reach of even the most powerful classical computers. But IBM's vision extends beyond hardware. They're also pioneering advances in quantum software with the development of Qiskit, a widely used open-source software for quantum programming. This software allows developers to write quantum programs and run them on real quantum hardware, opening up a whole new world of possibilities. IBM Quantum isn't just creating quantum computers, they're building an entire quantum ecosystem. Quantum computers are powerful, but what good is a tool if you can't use it? Quantum computers are like a new language, and like any new language, it needs a translator. That's where IBM's Qiskit Quantum Software Development Kit, or SDK, comes into play. Qiskit is IBM's open-source software platform that helps developers program quantum computers, essentially serving as a bridge between the complexities of quantum mechanics and the digital world we're familiar with. It's like a Rosetta Stone for quantum computing, decoding the intricate language of qubits into something we can understand and utilize. But what makes Qiskit truly special is its accessibility. IBM has made it open source, meaning anyone, anywhere can access it, learn from it, and contribute to it. This is more than just a tool. It's a global classroom, an all-access pass to the forefront of technology. Qiskit also allows for the creation of multidimensional computational spaces. Picture a Rubik's Cube. A classical computer would solve it one move at a time, but a quantum computer using Qiskit can analyze all possible solutions simultaneously and select the most efficient one. And that's not all. IBM is constantly working on improving Qiskit's performance. They're exploring error correction and error mitigation techniques to reduce the noise in quantum computations, making them more accurate and reliable. Qiskit is not just a piece of software, it's a quantum leap in technological capability, a powerful tool that is shaping the future of computing. It's being utilized by developers worldwide to solve complex problems that classical computers struggle with, from modeling molecular interactions to optimizing logistics and supply chains. But perhaps the most exciting aspect of Qiskit is its potential. As quantum computing continues to evolve and mature, the possibilities for what we can achieve with Qiskit are limitless. It's like we're standing on the edge of a vast ocean, ready to set sail into the uncharted waters of quantum computing. With Qiskit, IBM is not just providing the hardware, but also the software to shape our quantum future. Indeed, we're not just observing the quantum revolution, we're actively participating in it, programming our future one qubit at a time. So, we've talked about qubits, quantum superposition, entanglement, and even quantum programming. But what does all this mean for you and me? Quantum computing is a game changer. It's the key to unlocking solutions for complex problems that classical computers struggle with. Imagine a world where we can accurately predict weather patterns, develop new life-saving drugs, or even solve the mysteries of the universe. It's not science fiction, it's the quantum advantage. With quantum computing, we're not just solving complex problems, we're transcending the boundaries of what we thought possible.